Let's have a discussion about the slope of the two parallel lines. So the parallel lines that I'm taking, they are non-vertical. So whenever we are talking about the parallel lines, so we mostly take the two vertical lines like this, standing lines basically. But here we are not taking the standing lines, we are taking the lines which are slant. Okay, so let's talk about. So let's just a second. So let's make it here. So this is the y-axis I am making. Okay. This is the x-axis I am making. Correct. Now on that I am making two lines and lines like this. One of the line is this, same parallel lines here. So this is the second line that I have made. Okay. So this is y-axis. Okay. This is the horizontal line is the x-axis. Correct. This one is line L1. This one is line L2. Correct. Now, because we are talking about their slopes, so we know that what is slope? Slope we are representing by small m, or we are representing it by tan theta. So basically, what is slope? Slope is nothing, just the angle that the line is making with the positive x-axis. So if we will talk about line 1, so this is making an angle with x-axis. Let's take this angle. This line is making an angle alpha with the positive x-axis. So positive x-axis is this one, right? Similarly, line L2 is making an angle with x-axis as beta. Okay, beta. So you know that whenever we have two parallel lines and there is a transversal, so this angle, one inside angle and one outside angle on the same side of the parallel transversal is the making the corresponding angle. So angle B, angle alpha and angle beta, they are the corresponding angles. So when two lines are parallel, so we know that because they are so we can say because L1 is parallel to L2. So therefore, the alpha that is equals to beta. The angle alpha is equals to angle beta. So if we will take tan both sides, tan theta, tan both sides, so it will be tan alpha is equals to tan beta. So what is tan alpha? According to line L1, tan we are representing tan theta or alpha, we can say we are representing that the slope. So this is slope for line L1. So we can represent it as M1, and tan beta is the slope for the line L2. So I am taking that M2. Okay. So when the two lines are parallel, the angle they are making with the positive x-axis is exactly the same. And so that the slope is coming same. Okay. This is one of the reason that the slopes are equal. Correct. Now let's discuss more about this. Now understand everyone, that alpha and beta that I have taken according to the lines which are parallel, they are obtuse angle, because this is the positive axis and this is the line. So this angle, if you will see, this is more than 90 degrees. So this is an obtuse angle. So alpha and beta, they are obtuse angle, right? Obtuse angle. So let's discuss more. That let's take an example that whether the angle that we have made with the positive x-axis by the line having the slope equal or not. Let's take an example, right? So what I will do, I will draw a line which is parallel to x-axis. Okay, I'm drawing a line which is parallel to x-axis, right? Like this. So now what I am doing, I am taking this triangle. Okay, one of the triangle, I am taking this one. And the second triangle, I am taking the bigger triangle, this one. Okay, so I'm taking this point as A, this point I'm taking as B, and this point I'm taking as C. This point I am taking as D. This point I'm taking as E. Okay, I am taking these points. Now, please understand one thing. Now, let's take some values on the x-axis and y-axis. So, this is 0, which is the intersection point of both the axes, 0. Let's take, I'm going above y-axis. So, let's take this one as 1, this one as 2, and this one as 3. And this distance from the point D distance from the x-axis I am taking as 1, and this distance I am taking as 2. Okay, on the x-axis positive I am taking 1, 2, and so on, like that, right? So let's take triangle. In triangle AB, not AB, BD. Wait, you will take triangle. Wait a minute. Let's take the smaller triangle first. BCD. Okay. Very important thing that you have to understand. What is this angle? Now see here, everyone. I'm just changing the color to make you understand one thing, that this angle is alpha. with the positive x-axis. What is this angle? We know that this is a straight line. If one of the angle is alpha, this is 180 minus alpha because the complete angle is 180. So if one part is alpha, the another part is 180 minus alpha. So this angle is 180 minus alpha. Now, if we will see two lines, the line which I have drawn parallel to x-axis and the parallel axis are parallel lines. And if this is a transversal, then this angle is equal to this angle. So this angle is also 180 minus alpha. Similarly, if this angle is 180 minus beta, so this is also 180 minus beta. Okay, so this I am writing as 180 minus alpha, and this I am taking as 180 minus beta. Okay, now let's have a discussion. In triangle BCD, tan, I'm talking according to this angle, 180 minus alpha, that is equals to perpendicular over base, because tan theta is perpendicular, that is opposite side over the adjacent side. So perpendicular is the adjacent, opposite side is BC and the adjacent side is CD, right? Now, that is tan theta. So if we will see the distance, the BC, so what is the distance of BC? From C to B, if we will say, it's 1 to 2, only 1 unit distance, so it's 1, right? Similarly, what is CD? The distance from 0 to 1, because D point is at 1. So this is 1. Okay, the same distance. So from 0 to 1, if you will see this distance, this is 0 to 1, that is 1 unit only. So exactly the same because they are parallel. So 1. Now, please understand one thing. Tan 180 minus alpha. So tan 180 means whenever you are subtracting 180 something minus or 180 plus, the function will be the same. And 180 minus, we are talking about, because this is 180, like 0 degree, 90 degree, 180. 180 minus means we are talking about the second quadrant, and second quadrant tan is negative, obviously. So this is minus tan alpha, that is equals to 1. So basically, what is tan alpha? Tan is alpha is coming minus 1. Okay, so this is the slope for the line 1 example. Now let's talk about the slope for line 2. Same thing. So for that, what we will do, we will take triangle ACE. Okay, this point is E actually. This point is E. So same thing I will do. Tan 180 minus beta, that is equals to AC over CE. AC over CE. Right? AC over CE. So if you will see the distance of A, C to A. So 1, 2, 3. So basically two units. And from C to E, from here to here. So from 0 to 2, it's 2 unit only. Right? It's 2 unit only. So 2 and 2 cancel out, left over 1. We know that tan 180 minus beta is minus tan beta. Minus tan beta. So minus tan beta, that is equals to 1, and tan beta is equals to minus 1, because I'm taking the negative to the next side. Okay. So tan beta is equals to minus 1. So I'm writing it here. So we know that minus tan beta is equals to 1. So tan beta is equals to minus 1. So if you will see tan alpha and tan beta, they both are coming same, minus 1, minus 1. So this is how we can prove that the slope of two parallel lines are same. Either they are perpendicular, either they are vertical lines or non-vertical lines. Okay, either they are making the acute angle or obtuse angle, the slope would be the same for the parallel lines, right? So yes, thank you everyone. Thank you so much.